Welcome to the first episode of the AQA GCSE Engineering Revision Series. Today we'll be going through 1.1 Materials and their Properties. This is an excerpt of the official specification, which will be linked in the description. First, toughness and brittleness. Toughness and brittleness is the ability of a material to withstand impact without fracturing, and it's basically two sides of the same coin, whereby the tougher the material, the harder it is to fracture upon impact, and the brittler the material, the easier it is to fracture upon impact. One common misconception is just because it's tough means it won't bend. This is not true. Let's take a look at Stephen the steel nail. Although it has been bent, it has not yet fractured, so it is tough. In contrast, glass is extremely brittle because it fractures and breaks very easily upon impact. Here are some examples of tough materials. Next, strength and stiffness. This is the ability of a material to resist deformation. And deformation basically means bending or changing shape. This steel bar isn't bending even with a lot of force being applied, suggesting that it is very stiff. Stephen the steel nail, however, has been bent, suggesting that it isn't very stiff. An example of a really stiff material is steel bars. An example of a material that's not stiff is aluminum foil. Next, hardness. Hardness is... what was that? Never mind. Hardness is the ability of a material to resist wear or abrasion. Wear and abrasion basically means scratches or dents. One thing to note is that hardness usually comes with brittleness. Hard materials are used to make drill bits and angle grinder discs because they can abrade other materials without losing sharpness. The harder the material, the more difficult it is to machine, which makes sense. For example, facing off relies on shaving off layers of material, and it would be difficult to scratch off material from a material that is hard, which resists scratching, right? Here are some examples of hard materials. Ceramic pots are hard but brittle, but tungsten carbide, which is also a ceramic, is very hard, very stiff, and very tough. Ductility. Ductility is the ability of a material to be deformed under tensile stress, which is a stretching force, without breaking. Or we can think of it as how well a material can be stretched into a wire. This also determines a material's ability to be extruded. The more ductile a material, the easier it is to machine, because being ductile means that it is soft and can be easily shaped. Copper is extremely ductile. Because of this, and the fact that it is a very good electrical conductor, it is widely used in electrical wiring. Aluminum is ductile as well, allowing it to be extruded and used to make aluminum bars. Malleability. Malleability is the ability of a material to be deformed under compressive stress, or the squeezing force, without breaking. And this is very similar to ductility. Usually, if something is ductile, it will also be malleable. And just like with ductility, if something is more malleable, it would be easier to machine as it can be easily shaped. However, a material that is malleable but not ductile is lead, as it can be pressed into shape but will break when pulled apart. Gold is also very malleable, and that's why it's used for jewelry, which requires intricate detailing. Other important properties include electrical conductivity, which is the ability of a material to conduct electricity, temperature resistance, which is the ability of a material to conduct or insulate heat, and chemical or corrosion resistance, which is the ability of a material to resist corrosion or reaction with external chemicals. Now, what are the properties of the following materials? Pause the video and list as many properties as you can.
3, 2, 1, go!
Here are a few properties of these materials. Thank you for watching. The slides will be linked in the description.